Hello and welcome to the 18th, I think, video in this series making simple floppy robin for Android using Cocos2dx. So in this video then we're going to start the first of what's going to be a couple of videos going over the biggest pain of the lot, which is the scaling of the various parts of the game, accounting for different resolutions and aspect ratios in Android. And this is the biggest problem with developing for Android, is the fact there are so many different devices, and it becomes a bit of a pain having to deal with all the different aspect ratios and things like that. Anyway, there is a way of dealing with it, and the way I'm going to do it in this project is a bit back to front. I would highly recommend what we're going to implement in the next two videos you actually do at the start of your application, but I wanted with this series to get straight into the graphics and things actually happening on the screen so it stays a little bit interesting, rather than start with the scaling. So we're going to be doing things a bit back to front, and unfortunately that makes it slightly more long-winded. Well, it will do in the next video. This one, however, is sort of more setting the groundwork. So onto the scaling. There are, depending on what kind of application you have, there are different types of scaling you need. So for example, the Traffic Light Mania game I did had fixed maps based on roads going up and down and left and right, which meant I had to maintain the same proportion of the maps both in the X and the Y direction, which meant some quite tricky code, which was okay once it was working, which either places a frame depending on the aspect ratio at the top of the screen and bottom, or on the left and the right. For this game here, however, the most important thing for the game that affects the gameplay is the gap between the tubes and the relation of the size of the robin to the size of the gap. And this is all based on the Y, so how big the Y is. So we need the proportion, irrespective of how many pixels are on the screen, we need the proportion in the Y direction to stay the same, and that also includes the amount the robin jumps and falls. So our most important scaling is the Y. And when we do this Y scaling, we still want to keep the shape of our clouds, our mountains, trees, and obviously the robin needs to remain relatively circular, and the tubes need to remain the same size that they are now. So what we're going to do in proportion to the robin then is we'll scale everything in the Y, all the sprites based on the Y scale. So for example, at the moment we have a base size of 640 high. So if we had, say, 500 high, then we would have a Y scale of 0.8, and that means we would set the scale factor for all of our sprites to 0.8. We would then also set the gaps for the tubes to 0.8. The speeds and everything don't matter because they're set in seconds, but the gravity multiplied by 0.8, and the speed of the robin upwards also 0.8. So everything will be multiplied by 0.8. However, the gaps for the labels and things to the edge of the screen will calculate for those a scale in the X direction in the similar way we've done for the Y, and these gaps and things will all be then set using the X scale for their relative direction and the Y scale. So you'll see how all that comes in. The other thing that we have to also bear in mind is the use of the graphics. At the moment we've got graphics based on 960 by 640, but if somebody comes in with half of that, 480 by 320, then we're using a lot of highly detailed graphics that we're not going to need. So we're going to supply three sets of graphics as well. One is for 480 by 320 and less, one for 960 by 640, and the other one's actually for over 960 by 640. So I'll just stop the application now and stop blabbing on. In the project itself, I have inside the resources section, and you'll have these for download, already added. So for instance, for the mountain here, ND means normal size, UHD is then the ultra high definition, and we've already got the -HD. And what the program will do is the game manager on startup will calculate which file extension we want to use and what all the various scale factors are. So now I've blathered on enough about the setup. Let's get into doing the programming. We've got quite a bit to do. I could copy and paste because I've already prepared this to check that it all works, but I'll type all this out because I often get comments saying that you prefer that than the copy and paste. So without further ado, here we go. We need then to get our scale X. We'll need to be able to get our scale Y, as I've just talked about, and we'll also need to be able to get our scale factor as well from our game manager class. The other thing we want it to do right at the start, so when our splash screen is loading, we'll set up our scale factors before we do anything else, adding any sprites or anything like that, and this function then will be used to, like it says, set up all of these factors. The other thing we're going to make is, if I go to helloworld.scene.cpp, a bad thing that's been done here is I've hard-coded in the file names here, which is okay when it's -hd, but obviously we're going to choose now between nd, hd and UHD. And to do that, that means either using strings with the std :string object provided by C++ library, or using characters and doing it the C way. Well, I prefer to do it the C way. I don't like using IOStream and string and these things unless absolutely necessary, because they're just too big and bulky, and I guess it's just a habit from the C programming. So what we're going to do to shorten doing lots of sprintfs or something in every function, we'll just handle all that inside the game manager. So here I'm going to write get file name, and what this will do is it'll take a pointer to character, which will be a character array. We'll send in the length that we want for the array. We'll send in the name of the file, and we'll also send the file extension as well. So I'll just call this file extension like so, and not knar, should be car. So this will then be used, this function here will then simply populate this array with the correct file name. So down into the private section then we need to add in obviously some more variables as well. So we'll have the scale x, we'll have the scale y, we'll have the scale factor, and we'll have the file extension as well. I've just made yet another spelling mistake, but you're probably well and truly used to those by now. Okay, so that sets up the header section then. And why is it complaining about char unknown type cat? Oh, it's probably still from previously. I'll just call build here to hopefully get rid of that error there. I love Xcode. I think it's a fantastic IDE, but I really do hate the way that the errors stay for a long time after they've actually disappeared. Okay then, so into GameManager.cpp, let's copy these functions here and start setting them all up, as is customary by now. So see Game Manager, wrong place, and let's add in the brackets. Oh, right. Okay, good. So here the simplest functions of all, so we return our scale x, let's return our scale y, return our scale factor, and we'll come back to set up scale factors. Let's just cover the code that's inside the get file name first. First thing I want to do is just call memset on the array to clear out what was in there previously, and with size of, and then we've got a character multiplied by the length, the number of characters we want to clear. And now we can use sprintf on our array to put in the name of the file, the extension, and the file extension. So we have name, our extension that we have, and then the file extension like so. And now we can go back then looking up to into the setting up of the scale factors, which is the trickiest part. I'm just going to drop into helloworld.scene.cpp and take out this origin because we don't use it, and get the visible size, and go back to Game Manager because we'll be needing the visible size. So the first thing we'll do is we'll set up our extension, but before we do that I want to go to the top here and just add in a couple of definitions. So I'm going to call this k extension HD,
and that's a dash and HD. And as you're probably familiar now, most of the time, not all of the time, but most of the time, I like putting stuff as constants. So ND is for our normal definition, UHD for our ultra high definition graphics. So let's set our extension then equal to, and we need to cast this to a car pointer not to get a warning, and the standard HD, and our scale factor at the moment is 1.0. Everything is based on the 960 by 640, and those are the graphics we're using. But we'll say that if the visible size dot width multiplied by the visible size dot height is greater than 960 multiplied by 640, then let's change all this and start using our high definition. So our scale factor is now 2.0, so everything we've got as gaps in it as X or Y or fonts or anything like that are now twice as big as previously, because we're going to be basing on the graphics that are twice as large, or 1920 by 1280. The other thing we need to do then is change our extension now to equal to, and we want K extension UHD. Otherwise, we might have another situation where the graphics are very small. So if we say the width times the height then is less than 480 multiplied by 320, then we'll just use our normal definition. So now we've gone scale factor 0.5, and we're going to have the extension ND. Now that we've done that, we can set up our scales in the Y direction. So the way we do that is we have our scale Y, and what we want to say is that is equal to the visible size dot height. Now imagine now that our height is actually the 1280, so we've got double the resolution, so we're using our ultra high definition graphics. Then, but say it wasn't 1280, but it was actually 1000, so we would still be using the ultra high definition graphics with a scale factor of 2, but we want to know how much we need to decrease by based on 1280. So in that case around 0.8, so we would want this to come out at 0.8. So we have our height of 1280, and we need to multiply then by our 640, which is our base, multiplied by our scale factor, like so. Divided by that, which will then give us effectively there our 1000 divided by 1280. Obviously, if we were using the normal graphics, we would just have 640 multiplied by 1.0 and the smaller size by 0.5. So that gets us our scaling based on the graphic size that we're using. And we can do exactly the same thing for our scale X. Scale X, except this time we're going to use the width, and the width obviously is 960 that we're basing things on, multiplied by the scale factor. Last thing I want to do here, just very quickly, is drop these. So scale X, I just want to print these out to the console when we start the application to check things are okay. I'm going to use just one decimal place for that, and just realized I need the percentage. I'm going to be lazy and copy and paste this. So on the scale X, the scale Y, the scale factor, and also let's have the extension as well. So we'll just say extension and percentage %S. So scale X, scale Y, scale factor, and the extension as well. Okay, so this sets up then our scale factors. Now let's just take this function here and drop into splashscene.cpp before we do anything else, and inside here we'll just go cGameManager instance and set up the scale factors like so. And I always mess that up, so I'm just going to click build now and see if there are any major errors or anything like that before I carry on. Okay, good. So if I run the application now, I should be able to, in the console, see the scale factors dropping out. And just below, I'll just move the application here, we've got scale 1, Y scale 1, hang on, let me turn the music off. Scale 1, Y scale 1, scale factor 1, the extension -HD. If I go into the app controller, which is main I think on the Windows project in Visual Studio, and just change this then to being a lot smaller, so 480 by 320, and run. And I'll stop the application so I don't hear the music. Scale X is a half, scale Y is a half, scale factor is 1.0, which is incorrect, and the extension is -HD. So I'm glad I checked that. I've already made an error there. Why have I made an error? Because I want it to be less than or equal to 480 by 320. Okay, I'll just run this again and double check all this. Okay, that's better. So we've got scale 1, Y scale 1, scale factor, however, is 0.5 based against the -ND graphics. Okay then, so that's setting up our scale factors done. And now what we need to do is the worst part of this video, maybe the whole series, which is actually we need to start writing out a set of macros to be able to use all of this information, because what I don't want to be doing is typing CGameManager : instance and stuff like that with the functions. Otherwise we're going to end up with some very long bits of code. So I'm going to shorten this using some macros. So we're going to say get scale X first of all, CGameManager, and I promise I'll get around to copying some of this in a minute. And we want get scale X, and I've made a spelling mistake I think I saw with that. I'll just put the first bracket around there like so. So that's the get scale X. So wherever we put that in our code, as long as we obviously have CGameManager defined in the header, then we'll be able to use that. I want the get scale Y, and the other one we need is the get scale FAC for get scale factor. The next thing we want to do is we'll need to, you remember I was saying about the X positions and the Y positions of labels and things, we'll need to be able to actually scale those in the relevant direction. So we'll scale something in the X direction, just an arbitrary number, which means we then have our P multiplied by and then get scale X. And then what we'll also do here is our P then multiplied by the get scale Y for when we want to scale something in the X or Y direction. And the next thing I want to do is scale a position. So we use usually CCP, but we're going to want to often scale our position in the relevant X and Y directions for the position of something going on the screen. So I'll scale position X and Y. And what we'll do now then is say that we have a CCP, and now what we want is our get scale X multiplied by our X, and of course critically multiplied by our get scale factor as well. Remember, we need to do this because we double our points in the case of the ultra high definition and halve them in the case of normal definition. And I'll just do this here with the Y and the get scale factor, like so. Okay then, so that scales a position, replacing the C, so we'll replace CCP basically with scale pos in many points of the code, not all though. Now we want to be able to scale a font size, so I'll just put a P in there again, and a P, and this time we want to multiply that by our scale Y, because we want to scale fonts and things like that, remember, based just in the Y direction. And then again we'll want to multiply this by our scale factor. And now what I want to do is, I've got this get file name function here. It's going to be a pain to have to type that out all the time, so I want to shorten things here and actually shorten the get file name. So I'm going to type another definition, and call it get file name, and we've got our array and our length and our name and our file extension. And when you're doing macros, you're probably familiar, but if you do macros on more than one line, be careful not to leave any white space after the slash here, otherwise with some IDs and things can go a little bit wrong. But we want CGameManager instance and the point here. And then I want get file name, and then we have our A, our L, and our N, and our E, like so. And I'll just surround that by another bracket as well. Now what we want to be able to do is some of the sprites will need to scale in the X and Y direction. So we'll want to scale something by X and scale it by the Y scale, but other sprites like the robin will want to just scale them according to the Y scale. So I'm going to define and say scale node and just put X and Y here, and N is then the node, and we'll say the node and set scale, and set the scale X with the get scale X. I'll just copy that. And here I want then obviously to set the scale Y with set scale Y with get scale Y, and I'm going to take the semicolon off the end of here because we'll actually put a semicolon on the end of this because I find the code a bit easier to read. And last but not least of all of our macros here, then going to scale node just with the Y scale, which means we set the scale of our node just plainly with the scale Y, like so. Okay then, so that's not all, but it's most of the scaling code now in and ready to use. The next place I want to go now is into constants.h. Just to finish off this video, I just want to change up the constants in the relevant places so that we're ready to implement this stuff in the next video. So the robin speed upwards obviously now is going to have to be scaled in the Y direction and also by the scale factor. Now I'm aware that I could have written a macro as well that combines these two together because I've done that a lot, but it's becoming a bit too much with the number of macros and things. I prefer to have it like this so it's easy to read. So we want to scale the robin's upward speed by our Y scale, now scale factor, and likewise the start position for the robin will be done by the X scale. The scales of the sprites and things, however, trees, mountains and things, will be just multiplied by the Y scale because those are all based on that. The restart X's, sorry if you can hear a lawnmower in the background, obviously are scaled according to the X pixels. The speeds are in seconds, so it doesn't matter. The offsets again are X scales. The spawn times don't matter. And now all of the gaps are based on scales in the Y direction. So I can just take this here and multiply all of these like so. And last but not least, the gravity also needs to be scaled correctly so the robin behavior when it's falling remains the same. So now I'm going to build this, and we'll have some errors in here, but I want to build it so I can find the errors relatively quickly. The first error should be in hello world.cpp. It is, we need to cast this value here now to an int. What results from this? And I'll just build again, that error should disappear now. It does. And the other errors will be inside, at least I thought we had to cast that to an int. Oh sorry, I've casted the wrong bit to an int there. I need to cast this to an int. Okay, and inside the robin, I don't think it has access to the game manager, so we'll include our C game manager like so, and I think we can now get rid of constants there and just build again. And things seem to be building okay. It says failed. Why is it failed? Okay, robin state moving. If I missed something very simple off here, one moment, just try and build again. I thought we'd included constants and everything should be okay. Anyway, okay. Things are built now, good. So that's everything built. The application itself should run exactly the same as before. And it does, except now of course we've got some problems running on this smaller screen and everything because we haven't actually scaled anything yet to the smaller screen, but we'll cross that bridge in the next video. So I hope that makes some sense. Thanks so much for watching, and comments, questions, criticisms welcome as always on YouTube.